Hello. Welcome. Today we're gonna work on the Runahead. I'm just gonna say yeet all this and just use these notes that I've refined over time. So in the Runahead key. So far, we've made the system of whether or not it checks if an instruction is coming to the run ahead. So I need to review this input, make sure that works. I need to add bits for the program count that control what speculation state it's in. Then yeah. I just realized this stall should actually come out of here. Because this will actually tell the system that it's, if neither of these instructions are valid, then you stall. Well, not really. I don't even need that, because this would just put a non-valid instruction or let the pipe just kind of flow. Yeah, wouldn't need that, otherwise the program counter would keep going. Catch myself up. Oh, I know with the stat cache was a fun thing that I kept going back and forth with when I first started. But now that we finished the shadow reg file, the 4 detection, last time we finished all the branch prediction stuff on Wednesday, and we wrapped up the program counter. We have operand validation. We wrapped up this last time. And this one. In the Runahead Queue. Okay. Okay, so this would be instruction input. We need register status. Instruction output. Yep. That's proper with the program counter. Doesn't need to really talk, but needs to talk to this. Okay. So the Runahead Queue, when I inject, I need to have a bit that says, hey, I'm speculative. And when that bit comes on and says, hey, I'm speculative, I need to mark that entry, and then per this, I also need to increment and decrement the flag. So I need input, calculating, and then I also need a
Yo, Raymond in here or no?
Yeah, what's up?
hey.
Hey,
I also need a miss.
your video's only on YouTube, right?
Yeah, right now it is.
We'll be back in like 5 minutes.
If you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired
What is it? There it is. Oh, I can only do 2 keys. Okay, control shift. Awesome. Need just a moment. I'm setting up my stream deck so I can actually like do things properly. Awesome. Okay. Now I can mute myself easier. Not muted. Okay. I think these are the only things I need. Yeah, because an instruction comes in. So this stall comes in. I don't know. It's just generally stalled, so I can. Don't think I'd ever really need that, but I'm gonna have there. I need to think through that one. Then the Runahead FIFO full stall. This would be like, hey, you're trying to inject, put something in here, and you're full, so you have to stall. And then I have the interface for the valid, so an instruction will come in here when it needs to run ahead, and it'll say, hey, my operands that were dirty would have been forwarded. And if you come in and you're at the head of the run ahead queue, and the only issue you have is with an operand that came back that, hey, this was dirty, but it would have been forwarded. Like if you needed a operand for A and B operand, A would have been forwarded, and B was a load from memory. When your instruction comes up to the front of the run ahead queue, A will no longer be marked dirty will no longer be like marked bad for you. You'll allow you to come through regardless, because it knows that, hey, that was clean. Let me actually double think through these would have forwarded real quick. So an instruction comes through here, comes in here, and then A is coming through. Not marked dirty at all because it comes through here and it's just coming. Comes back and writes. The instruction went up there. Why would I care that it was that A was forwarded? I don't care if you were forwarded actually at all. I don't know why I marked that. Because if you're forwarded, even if like there's 3 instructions in a row that were have A marked forwarded, they got pushed to the run ahead queue. If they come through normally, since they're being put through the forward detection anyway, again, when they come through here, that it's going to be reevaluated, so it doesn't matter. Yeah, and then I have load to be written. Hold on, I just realized something. Okay. Oh, okay, so I do that forwarding detection here. Gotcha. Thank you, Linter. Oh, these are supposed to be 2. Hmm. Da di da di da di la da. Ah. So I can't believe, like, because I'm a hardware person, that I went like a year and a half, 2 years working with system Verilog and didn't have my a linter set up properly, and it would save me like so much effort.
About the linter?
So yeah, it's like God tier.
Yeah. Really nice time saver.
You're like right here, look, detected there's 2 forward A outs, and there wasn't a B, and I was able to find that. Oh, like so many of those little things when we were debugging, like pORC1, where I went, oh, bit width or those random issues. None of those problems are a thing anymore. Like I caught like every single one in my last like 6 files well before I even tested. When I tested, they just ended up working.
All the test beds catch that typo crap. For the RT, you would throw it in the quarters.
So yeah. I also was looking over like the other streams and stuff, and I've realized that long-term view wise, streams closer to 2 hours get like 3 to 5 times more, like consistently more views than longer ones. I think it's just because it's less intimidating to see like, oh, that's only 2 hours. I could put that on the background real quick or something. So I'm gonna stick to these things like 2.5 hours versus like 4, since I'm not really going back and forth as much.
Good.
So I think that covers everything. I don't actually need the would have been forwarded. I'm just gonna comment them out in case in case something I end up like, oh, you know what would be really nice if I had these flags. Okay, so then so what I'm gonna do is I'm going to have a I'm gonna split up my I'm gonna split my valid bit into its own vector. I'm doing that because I'm gonna use a RAM like unit just to make this streamlined and more faster and clean. But you can't really reset one of those that easy. And since it's only gonna be like maybe 32 or 64 deep, I'm just gonna make a single bit vector that I'll just clear to 0 and then then whenever I write an instruction to it, I'll just set that bit index to 1. Oh, yeah, I'm gonna make it a shift register because I can make the logic a lot cleaner because you'll only ever be modifying the bits you shift in or the bottom. Okay. Okay. So I'm gonna have a valid vector that has a 1-bit entry, and then to make the logic simpler, I'm gonna have you can just clear to 0, but then I'm gonna have a finding the lowest highest one circuit. So I'm gonna shift left by 1, find the highest one, and then that'll tell me the next open location.
Right.
And yeah, and then whenever since that'll tell me, okay, in the output of that I'll just decode and then OR it with it, and that'll put a 1, that'll mark that next highest location as a 1 via that OR, and it'll write back. And when you're clearing a single instruction, it'll shift right by 1, and if you clear misprediction, it'll just shift the entire thing equal to the speculative value. because like there's a counter that goes up every time you add an instruction to this when you're speculating, or remove an instruction when you're speculating. It'll add or subtract 1 to that counter, so it knows its running total of how many instructions deep there is in it that are currently speculating, and it'll adjust accordingly.
What's your level of experience with the Runahead Queue?
This is my first time I've made one.
You studied one?
I studied a bunch a while ago. I love the idea. I'm doing it a little bit differently though. Just thinking. I don't think I want this valid vector. Yeah, I'm not even gonna do. I can do the logic without it. It'll just be a little bit weirder, but I feel like that's just adding way too much complexity to get around a stupid problem that I don't think is gonna be that big. I think I just need to, when it writes, it just needs to blindly push instructions into it. And by it being not empty, I'll know the front of the queue will be full. Will have an active instruction I can scan. So the one thing that I'm curious about. Let's get Milton going.
Yeah.
Is like, say this is your Runahead queue. We'll just split it into like 8s.
You gotta try that new build. Remember that?
Oh yeah, you did mention that.
Rectangles.
So let's say this is a waiting instruction. So you have like a couple run instructions at the bottom of this run ahead that were added. Let's say you start speculating while there's stuff in your run ahead queue. The next instructions then get added and they're speculative. And my counter starts adding and it goes, okay, there's +1. Okay, and there's -1 or whatever like that, and you speculate. And then, because there's 3 scenarios, and then let's say, because there's 3 scenarios I have to deal with. I'm gonna write out the different scenarios, and then make sure I work through them all. Okay, so we have these are the 3 different scenarios we have. So if we have this scenario right here and we leave speculation and our counter is still active. Oh, we have one other scenario. Speculative. Run ahead. Speculative. So, okay, I think I just solved my own problem. Okay, so let's say, So right now, if this speculation right here is like, let's say this is true, and we end up like properly speculating on this, and if we end up properly speculating, there's nothing to really do on any of these. except this last one, which I'll get to. But if we mispredict on any of these, if we mispredict on this first one, we can either jump the head down, or we can wait until this instruction works its way to the bottom and then immediately jump to the top of the speculation. Okay. So we pretty much, so that way then you'd have like these instructions run ahead, and as soon if this was these instructions running through, the moment that this gets here, you would just jump this head there and you just skip over it. That's simple enough. And that would be an easy mechanism, because then if you were currently in speculation, like if you're currently in this state, or if these speculations are just, or if these are your only 3 instructions you have in your run ahead, then the front of your queue would be like, oh, I'm currently in speculative mode, and then you would see, hey, I mispredict as a flag. You know, just go, oh, well, I know my current count is 3, so I'm just gonna add 3 to my tail, go here, and I'm gonna be fine, because then I'll just skip ahead. But the biggest problem comes in something like this, where let's say this just now got to the head of the queue, and you know that this one was, in this scenario, this one was a mispredict, because there was a prediction, it was a valid, you're fine. But if these 2 were mispredictions, then you ran these and you started another prediction up here. As soon as this hits the bottom, you're gonna need to jump 2, but your counter's at a 1 up here. So the only thing that I could think of is this be a twofold mechanism. Have a system that scans this bottom to say, am I speculating? And is my active speculation a mispredict? And what I'll do is I'll have this queue that's just the speculative queue, this run ahead queue. Then I'll have a separate queue that's like maybe 4 deep. That if, let's say, you have a speculation counter that's 7 or something like that, or like in this scenario you'd have a speculation counter that's 2, and then this would be marked as a mispredict, but you didn't have it, but this condition wasn't met. So since the head of your queue wasn't speculative, you can't just apply this to immediately. So instead of applying it, you push it to this queue. That would be its own like 4 deep value. And then you just push it to here. And then the next time you see a speculative value at the bottom, you push 2. You just automatically clear 2 values up. So that way then this can have its own counter of 1. And when it's done, since if you get through these instructions and you're there, then it just uses this active counter. But if there's anything valid in this queue, then you push from this queue first to jump up.
Okay, so you push the queue until there's nothing left in it, instead of keeping like a counter.
Yeah, so what I do is I essentially say, hey, if this is a 2, and this could be is you could also have like a speculation 1, speculation 1, speculation 2, speculation 2, and then you have your normal run ahead up here. And then in this queue, you could have a 2 and then a 2. So what this would do is for the first cycle, it would see, oh, I have a 2, let me add 2, and you'd be pointing here. And the very next cycle, you'd see, oh, I have a speculation value. My head is speculative, and there's a value in this, which means that current 1 has to be cleared. So then the second 2 takes effect on the following cycle, and you come up to this run ahead. So even though the front end of the CPU is not doing like a bunch of shit, and the reason I want it this way is so that way if you end up doing like a load add jump, 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 whatever like that, so you can like iterate through branches and you're loading in like a bunch of stuff to registers, or since we have the stack register, you're just dumping values to stack. And then you have some instructions that you're using on all those speculative instructions that need to come through. If you have anything that operates on those, like you have increment the pointer, load the value, add 1 to the value, loop, and it just does that over and over and over, and then it like moves that value into the stack. So it loads into register 5, moves, and just goes through. This would allow you to have those individual things stacked up in here. And this, I wouldn't make this super deep because then that it gets too complicated. But I think this solves the last little like dilemma for speculation that I had. I'm about to get up in just a second though. And then, with that being said, I think I'm going to like, I'll put that over on this screen so I keep it in mind. Yeah, so these, I don't really care about these. This is the only one I care about. Okay. Do I have a simple like FIFO that I don't have to? No, I'm gonna make a new FIFO. Well, since I need 2 different FIFOs, I'm gonna make them. But one thing I'm gonna do is I normally have the full and empty bits be down here, and it's like their own thing that are and there's all this math. There's this math, so there's some latency. But to increase clock speed, I'm gonna have this. It's gonna be like I'm gonna do a pre-check on the full, saying like, hey, if you were to write on the cycle without a read, then it'll be full, and then there'll just be a 2-bit register that tracks whether or not you're full or empty. So you're reading any status you're getting out of this is like there's no timing. You're just reading from a register. There's no logic. Keeps all critical paths local. So, yeah, I'm gonna get up, stretch real quick, walk around, and then I'll make that queue. And then once I have that queue made, I can just instantiate 2 of them, and that takes care of the main Runahead queue itself, and that's the speculation clear queue. Speculative queue, clear queue. That's a fun one to say. And I should just need that and this then this counter set up right here, and that should be the entire Runahead queue. I have the counter. The counter feeds. Yeah, that's pretty much everything. Oh, hold on. I just realized. So since, let's say these are taken, so this is good. Like, happy face on all of these. I need to still push a 3 here, but I need a 3 and be like whether or not it was mispredicted. There needs to be a misprediction bit on these, so that way I know, hey, on this front I need to have a decrement that says, okay, since these 3 were good and happy, I need to then go 3, 2, 1. Okay, and now I can clear that entry. So then this will need to be its own like system. I may make this its own module. Yeah, I'll probably make that its own module. Huh?
What are you gonna call it?
The speculative Runahead speculative clear queue. But so I'm gonna get up and stretch. When I get back, I'm gonna make a new FIFO that has this buffered pre-check stuff, and then I'll use that to then make the clear queue, and then I can take that clear queue and the main buffer structure, those 2 combined, and that should take care of like 90% of the logic for this, and I just need to then glue that together and plug in the pins.
Good plan.
Yeah. So I'll be right back.
And
so you can see what you do. Restless every time we start locking as a lost control. Oh, it's paradise with honesty, but in the dead of the night, teardrops on the floor. The pain is over, feel the darkness take control.
No, there ain't no stopping us. Fly without a boarding pass. Couldn't catch me, I'll be moving fast. Call me a shooting star. Let 'em know who you are. Flying up in a bar. Wish on a star. Time to show 'em who's in charge. Call me a shooting star. Didn't even get to cross. I said I'm moving too far. Get to glass. Looking at a shooting star. Got more than a couple of people going mad. I swear they're rooting hard. Tell them I'd be big in the game like she went and got them breast implants. I said I'm moving too fast. Didn't even get to glance. I'm ready to eat up track like I'm seated in a restaurant. If you had swag like mine, you know it's best to flaunt. We aren't hating because you aren't. Shining like it's neon. Rock like kings of Leon. Shooting stars across the galaxy. I stand out, so don't be mad at me. Infiltrate, I'm with my strategy. When I turn up, then I just have to leave. Shooting stars across the galaxy. I
Hello. I is back. Oh. What?
I'm just eating some oatmeal.
What was that up?
Just having some breakfast. Don't mind me.
I see the light inside you, brighter than the skies. Hold on, just let us escape and fly away tonight. We have the world in our sight, and I know together we'll be right. Can you see forever we will go?
Okay, so I need to define to be full. To how do you know she's there? This is one big. All you gotta do is laugh sometimes. That's a good way to look at it. Hold on. If I to be empty, if the next tail index equals the head index. Why? To be. Yeah, I'm gonna go really bad naming. Oh, for a second. Okay, that works. Oh, that's actually even easier. That means I don't need. Oh. This needs to reset to be 0, 1 because it's going to start empty.
This is definitely not gonna work. Let's start with this as a 1.
This index has to be true and to be empty. Okay. And if you're not, because if that, I think that solves it. So if you're not already empty, because if you are empty, you're gonna be at 0 and 0. So since you're at 0, 0, you add 1 to your right, and because even though this is true, you're you were could be empty and okay, so you start off empty, and then when you do an input, you're gonna write to this, which means it's gonna this to be empty is gonna be cleared. So even though this, yeah, because then this will be valid. So if you then read on the next, it'll set it back to equal because they will have been equal. But if you're reading to it at the same time they're writing, then it's gonna cancel this because this is gonna move up at the same time you move up. Cool. So then this would be the same thing but in reverse. And then not. Awesome. That's gonna be so much better than this. So then if you're full, and the full logic should be the exact same but in reverse. I just realized something. That means I can make these don't have to be larger now because I'm tracking whether or not they're full or empty state, instead of having to need that extra bit to check. Means I can remove this. I'm just gonna grab the whole value. Okay. Now, even if this has a slightly weird, like longer critical path, it should be fine. Like the handshakes have a couple gates to go through, but that should be fine. Okay, I'm just gonna validate that this works. And then once I validate that this works, I can use it for the other things. 9. Nine gets written. Then A, B, then 9, then B. Awesome. Make this only 4. B 9 and B F and then 1 0 is rejected. And yeah, the full definitely does not work. You have 1, 2, 3, 4. Oh my god, Lord, I'm so fucking stupid. There you go. Now it should actually be 4 fucking deep. 9 A B C. Awesome. Then rejected. And then you take out 9, and then on the next cycle, awesome. And I want to make sure it drains properly and goes back to. Yep. Yep, the last output comes out and then yep. Okay. That was a easy one and done. That was almost too quick and easy. This linter, I swear.
Nice.
Yeah. Because I love one thing I do like about making test benches is I can just do I can copy paste the module. That's the only good thing I like about it. So if I have like 32, that would be 6. Do depth. Let's just do like 8. Okay, so I think I'm just gonna have this actually be the whole. I'm gonna just incorporate all of the speculation stuff into this. I can literally just eat all this. Okay. Yeah, because I'll need a counter.
Lions roaring in the morning sun, searching for a longer day. People feeling like the light has
Run
just
ahead.
we must never stop the way. Yeah. Birds chirping and I hear my name, grasping into a life. Life is happy but it's so insane. We must merely make a start. Savannah, I'm coming home. Savannah, we'll never be alone. Savannah, the beauty of the world. Savannah, let's all take a walk. Savannah. Lions gonna come. The birds have just begun. We will always take a stand for the people, for the land. Let's go back to when we were young. For the animals we stand. Let's go back to when trees were swung. Kids across the land. Savannah, I'm coming home. Savannah,
Count amount of executed property speculated instruction.
Savannah, the beauty of the world. Savannah, let's all take a walk. Savannah, I'm coming home. Savannah, we'll never be alone. Savannah, the beauty of the world. Savannah, let's all take a walk.
Oh, cool. I got question marks too. I didn't know that.
Savannah, I'm coming home. Savannah, we'll never be alone. Savannah.
Is there a different color, right?
Yeah, it's just formatting.
I've got that Same extension.
I love it so much. Just a little bit of color. Oh, Mart needs to move in. Mart, how long were you waiting there?
Yeah, like 5 minutes.
Oh,
Oh,
hello.
my bad.
Why is this channel locked?
So I've ran so that way it's more acknowledgement that we're streaming when you move in here.
Yeah.
It gives you that mental check mark. So, oh, okay.
What?
If mispredicted, let's say if mispredicted, increment.
By Runahead, you mean speculation?
Huh? What was that?
Runahead. Does that mean it's the CPU does the speculation?
No, run ahead is not speculation. Run ahead can be speculative. So I'm adding. So we went into Milton earlier, and I drew this out. So the run ahead queue just allows you to go out of order. So if an instruction, if you want to execute requires a value that's you're waiting on to come back from RAM, instead of stalling the CPU, the instruction just goes to the run ahead queue.
So it's like a reorder buffer.
Kinda. But much simpler. Because you can only execute the instruction that's at the head of this, and you just put to it in order, so it's just a FIFO. And you have this FIFO come out, and as instructions come through, but you could have regular instructions, but if you're speculating, if you're in a speculative state, when you add instructions to the run ahead queue, the instructions that get added may or may not need to be executed. So right now, the system I'm making keeps track of how many instructions are currently being injected. Wow, did not expect that. Like how if this is the head of where you're currently injecting instructions, how many instructions deep you're injecting? Yeah. So this would count like 3 instructions, and then whenever you're done with this speculation, it would push this value into the queue I'm making, this 3, so that way the next time you get a value instruction in here that's marked speculative, this 3 will have whether or not it was mispredicted, if it was mispredicted, or if it was properly predicted. If it was properly predicted, then it'll count 1, 2, 3, and let those instructions go through. And then once it counts 3 instructions, it'll clear this value and go, okay, cool, the bottom entry is good. I can now go to the next one. But if this 3 was marked mispredicted, then it would just increment the tail pointer by 3, effectively just skipping over those 3 instructions.
Yeah, so it's like a fetch queue.
Yeah, so I can so I'm just going through and just streaming through there, so that way whenever you do speculative rollbacks, the only time this takes multiple cycles is if you did if in between 2 different sessions of speculation you didn't have instructions go through, like you went speculation here and then you got out of it and then you went back into it right here and you have 2 of them. That's why this queue, and this takes 1 clock cycle per speculation to clear, but that's a penalty I'm willing to take.
Yes. Very
So,
advanced.
pardon?
Seems advanced.
I'm kind of making this up on the fly because normally run ahead queues are made for, hey, if I need a value, if I'm relying on a value from memory, go into a speculative mode, and then the CPU's number 1 goal is to just generate memory addresses. And so it pretty much skips through code. It kind of like scans through code and stuff like that and tries to find things that generate memory addresses, just to generate just to get stuff into the cache. So then whenever you uninstall from that, you uninstall the primary execution.
Dynamic prefetch.
Yeah, so it's a dynamic prefetcher and takes advantage of, oh, I'm already fetching from memory, might as well stack that up with as many requests as I can.
Yeah. Get the burst speed.
Yeah, I'm doing that, but instead of just using it as going into prefetch mode, because the run ahead things that I've seen, not all of them, but a good percentage of them whenever you go out of run ahead mode, your PC rolls back to the point where you were stalled, and even though you rerun those instructions that generated those addresses, and it ends up being really efficient. It's not like a super bad thing, but I just don't like the idea of having to rerun all those instructions. So this system is made to where it just goes into run ahead anyway, and it just will always accept those, and I just have a mechanism in it to accept speculation. So I'm just kind of like mixing it together with a few things just to try to get a little extra speed so I don't stall nearly as much. Because I plan to write more complex stuff in it. For like the FPGA side of the debugger and stuff like that, this will run that. And when I run all that random code, there's gonna be a lot of I/O and like interfacing that it needs to do, and I don't want to have it like waiting forever on one thing. I want it to stall and like be able to like the software be able to clearly define hard limits for stuff to respond, but I don't want it to like, if it doesn't have to stall for it, I want it to be able to smartly adjust, be able to at least a little bit.
Right.
But yeah, I'm gonna get up and use the restroom and stretch because I really gotta use it. I've drank a lot of tea this morning so far. When I get back, I'll finish these notes, and then I'll finish the notes here, make the notes there, and then I'll be able to wrap this unit up, and then I can define all the interfaces it needs with here. And move this, copy this buffered FIFO over. Runahead Queue. Okay. Now I'm gonna get up and use the restroom. But yeah, I'll be back in a minute.
Thank God that the brothers on the rise now. Endless celebrations all in my house. Levitating now, I'm super duper fly now. London boy, but DC where I reside now. Put the time in while you always yelling time out. And for critic, cause I know I'm coming with it. You were sitting, you were wishing I was handling my business. Now I got the ball like Harry Potter playing Quidditch. And my business so humongous, you would think that happens in it. Damn man, I'm all that, yeah, I'm all that. Working for the
Hey Optimo, guess what I've been doing recently?
Piano? Playing the piano?
No. Finally using my stand desk as a stand desk.
Nice, nice, nice. It's great.
Yeah, I was always so nervous about having the cable length, and then the other day I was like, okay, my back was really hurting, so I like crouched down on the ground real quick and like slowly bumped it up really slowly, and I was like, oh, I got like 6 inches extra, hell yeah.
Back's been feeling bad.
I carried a really way too heavy book bag with the straps way too loose, and the pressure was all on my lower back, and it hurt really bad the day after. It was all my own dumbass fault.
Told you I went on that long bike ride. It was sore as a motherfucker, but at least it's not my back. It's just muscles. Get over that soon. Cold sucks. I went from riding my bike much at all to riding like 10 miles that day. So it was kind of extreme. I tend to do shit extreme and then regret it later.
With the weather like warming up on a more consistent basis here, I can actually I finally want to go back, start going to the fucking go out biking again, since I have the pass to the park and all that stuff, and I can go anytime I want. I just need to put the bike in the fucking thing and go.
It was gonna be cold up there. Is it today? Cold.
Today it's just dropping. Dropping like 10 degrees today. I know I've been debating whether or not once I get like farther about the time that I'll get pretty far with this, because the Runahead Queue is, as far as like complicated things to build, to get like the core CPU going, the Runahead Queue was like up there. The stack cache was one, like the number one on the complexity. And CSRs were up there, but CSRs aren't complex. I just have to work through the design for them. But I'm gonna not do CSRs at first. I'm just going to get the primary pipeline done, and then the load store, just the basic load store system, the fixed memory like we had before. Just since that takes multiple cycles, so I can test the run ahead system and things. But once that's going, I may go down to doing these only one a week, and then doing these just like Fridays and having Wednesdays go biking in the morning instead.
Recommend it.
Yeah. I like how this has been going. Like, there were so many like question marks. I just started throwing out like really garbage like hardware, then using that garbage logic to filter through things, and it's coming together really cleanly.
To be proud of, for sure.
Because I was already super happy with the first one, and the abilities to use the registers as fun stuff, and you can still use the registers as all those fun things.
You have a program in mind for these upgrades? Just gonna.
Yeah.
I mean, we're just gonna be increasing the. Is the main goal, right?
Increasing what?
Frequency. Mic.
Yeah, frequency and
shit.
effective IPC.
Yeah, IPC.
Because I want this to be the FPGA side of like the debugger. When you get it running, for you to export like data streams and stuff. The idea being is that this would be able to control. You'd replace like its I/O system, because you wouldn't need any of like the caches or anything. You could just use the fixed memories for that basic stuff. So you don't need the caches or any of these things. And the CSRs could be pretty much stripped for that too, which is one reason why I'm not gonna do that. I just want to optimize this and get all of our old code running that didn't have any of the CSRs or complex ALUs. We didn't have these before, so I'm not going to use those. I'm just going to focus on our old code and get that running with our basic stuff first. Because then whenever we get the debugger and stuff going, because I wanted to be able to have the ability for you to just like look at fill a buffer with a bunch of values and then dump it out and monitor them, like log statuses and things. And this CPU is what would manage those logs and then give you an interface out through like SPI or something like that you could send in, and it'll allow you to like interactively like look at logs and stream data out, so then play that back into the debugger. Hmm. Matthew.
Yeah.
Oh, just random tangent thought. You know how I've been thinking about wanting to be able for people to be able to like look at a module and then like record its state and then replay what it's doing. The hardest part about that is if that module has values inside of it, right? But what you could do is if you knew that like if there were states inside of it, the debugger could tap into all of those and add, if it's like if it's a memory block, tap into like the read and write stuff, like add extra ports to it just for the simulation purposes for like this debugger only. Tap into there so you can actually read, so you can read the values out of it, because all you need is a read port. And then have a read in all the registers, so the system, when you dump out and it gets the trigger, it'll then grab the starting state of all those values of those buffers and internal stuff, and then whenever you're done, it'll like go through and dump all of those states out. There'd be some complexity with it, but then whenever you were running the simulation, you could then have a quick little script that would go through and make it like a modified version of the code that would add in a routine to pre-write all the registers values. It could be a little complicated depending on the code, but it's an idea. Wait, definitely down the line, but I don't know. It's thinking out loud.
Yeah.
Okay, so if properly predicted. Oh, I just realized because I need to have a tail jump. Okay. Okay, so with this, okay, so this offset.
you know I never will. No, so I choke you down just like a pill.
Okay.
Take you like a pill.
Okay. So this bit with um I'm just gonna name it FIFO tail offset it.
Do me in the worst way. Don't let me sleep. Never say you're sorry. Oh, maybe I'll leave. Maybe, but you know I never will. No.
Okay. So then now it's just gonna equal 1.
Just like a pill.
That way by default this one's just gonna add 1.
Take you like a
I'm just gonna name this tail. Just shorten it. Okay. That was easy. Instead of adding too much complicated logic, I'll just fucking set it to that. Okay. Kind of bouncing around, but I'm making sure all this plays nicely. Okay, so now okay. That works. So I need input, speculating input. Fetch instruction valid. Fetch instruction valid. Input and speculation pulse. Input. So those are my inputs for at least the main thing. And I output Current speculative depth is the fuck. There you go. Current speculative depth. Okay, so I think that's it. All I have to do is I raise this bit high when I need to, I want to add to this. But speculative head of Runahead. So it's, if the instruction is at the front of the Runahead queue is speculative, because it's the speculative head of Runahead. Clear queue valid. This is Julio. But Runahead valid. I also need Runahead instruction valid. Okay, so when instructions, if I'm in speculation, I'm speculating, and the instruction gets added, I just go 1, 2, 3, 4. There's 4 instructions in there. Then I end. I end the speculation, which then pushes it to there with this upper bit mispredicted based on this mispredicted pulse. Oh, I also need a your queue full just in case. If you're not full, you put in the instruction, do whatever. Whenever you end speculating, push it to here. Yeah, this should be it. Because then if you're currently speculating and the queue is empty, but the head of you is speculative, then you just let it run and you just modify this counter accordingly, which is going to be covered in these next notes. So this actually should be the entire interface for this. I'm going to write the notes for this right here, and then I'm going to call it for the day. I need food before I start doing work stuffs. But yeah, work through all the random nonsense, clean this up. The Runahead queue itself is just going to be, well, queue. All this speculative bit, all this stuff is being moved into here to being managed by itself. To just pretty much say, hey, it just tells this to continue on. Pretty much all that cares about this head is whether or not it allows it to continue. That's the only real interaction that this needs from here, besides just snooping these bits. So it snoops these bits, and based on its current status from these inputs, It'll be like, oh, wait, no, clear the next 6 instructions. And it goes, oh, cool. And clears the next 6 instructions. And continues. Okay. Yeah. I'm happy with this.
What's that linter saying right there about line 29?
No, just can't find FIFO because it's in a separate folder. Doesn't really handle multiple directory is that bad. Like good, I mean. Okay, that's pretty much simple whenever the output's valid. think that covers it actually. So you have the input depth, and if the output of the queue is valid, that means it's dealing with its own fucking thing. And as far as Milton goes, that's any of these. So that covers any of these scenarios here. Because the queue has a value, but the current counter is at 0, 0, 1, or 0. That would be these states. But then when you have this state right here, where there's nothing in the queue at the bottom, but this top instruction has something, but you're currently adding speculative instructions, that state is where things get slightly more complicated, but that's just because it then has to act as a proper depth tracker. Because if you're issuing and queuing, you're effectively adding and subtracting a value, so it does nothing. But if you're just issuing without queuing, it subtracts and adds. And then when you end speculation, it needs to conditionally cancel the push into the queue. If this counter equals 0. That way it doesn't like throw in some dumb value. Like, oh, what's 0? I'm gonna just throw 0 and waste a cycle for nothing. So I was just thinking about what if you're currently you're outputting, let's say you're in another scenario, your entire queue is full of speculative instructions. If it's entirely full and you're still piping it through, and this instruction comes through where that counter stays the same, I don't give a fuck about what these instructions, marking them speculative or not, because the system's currently still speculating. So if the system mispredicts, I'm gonna clear this queue immediately. And yeah, I need to clear this queue immediately, which I need to add that cause for, and then these instructions in here will naturally just get flushed because, well, the pipeline's flushed on a mispredict. So I don't need to push. I need to so then if it's not valid, there's nothing to act. So then I just take this output and go, okay, cool, I'm just going to add that to the queue. And that effectively should mark it empty. Ooh! And with the buffered FIFO, since this checks whether or not the next is going to be equal, if I add like 7 to this and it's only like 7 deep, it's immediately going to be like, oh, you're going empty. You're clearing your entire queue in one jump. So it'll automatically detect this and put it into a nice healthy state. Okay. So yeah, that means next Wednesday I will actually write the code for these notes, which should actually only take like 30-40 minutes probably, because I thought through a lot of them and wrote them out. And then I'll write this code here, instantiate that in here, do a little bit of cleanup code, but the cleanup code's gonna be like fuck all, because like all these bits, all this logic's being handled in its own module. So it should be easy. Get this knocked out, and then by the middle of Wednesday session, we should be able to mark this Runahead Queue clean. So then we can go worry about the stat cache of nonsense. That should be fun. Yeah. Hmm. Oh wait, once this is fully done, I do kind of, if I ever go through and make CRV on ore like I have like all the main parts for, it can be built out easily to be the same run ahead. So I'll probably end up doing the same thing and just do like this same architecture but for RISC-V and run ahead. I may just ditch RISC-V for that though, because that's like I don't even care about that anymore. Okay. Yeah, I'm gonna call it here. Just then quickly be able to throw together this logic for both of these and get that knocked out. Bye, YouTube. Matthew, do you want to say bye to YouTube?
Later.
Bye.